for coming. I hope it's going to be all very interesting because the two gentlemen that we have here invited will be talking about the actuarial profession. And I actually don't know, I already forgot who is who, but one is Dave and the other is Michael. So Dave?
Yep.
Okay, and Michael. So welcome, and now it's their turn to tell us about their job.
Thanks for coming, everyone. Especially on a Friday afternoon. Probably not the best time, but it's a good turnout. So thanks for coming. So my name is Dave McGowan. I'm an actuary at a company called Towers Watson. I work downtown. Been there for about 10 years now. And this is my colleague, Michael.
I've been there probably 5 years. We do the same type of work. We're both actuaries in the company. There's probably about 40 people in our office in Vancouver. We've got offices globally. There's one of a handful of companies that do human resource consulting that hire actuaries in the marketplace right now.
So yeah, Towers Watson is a global company. About 14,000 employees worldwide. So that's just a bit of a background. So that's what we're going to look at today. What does an actuary do? Where actuaries work. Some key facts about actuaries, and how do you become an actuary if you're interested in the above three. Go ahead. So how many here, first of all, have heard of an actuary before today's talk? It's pretty good. So I think Mike and I are used to going to parties and people saying, what do you do? So you're an actuary, and then they look at you like stares. So
my parents don't know what I do.
So it's common for most people not to know what an actuary does. So we'll hopefully help explain that a bit. So the simplest way to explain it, maybe the words aren't simple, but actuaries estimate the value of future contingent cash flows. Okay, so that's quite a mouthful. Okay. So what do we mean by value? What that means is it's the present value in today's dollars. What is something worth today? Okay. So for future contingent cash flows, what that means is there's these future payments. We don't know the timing, and we don't know what the amount. We might not know what the amount is, and it can depend on an event happening or not happening. Okay. So that's what it means. That word contingent means it depends on an event occurring or not. So I like to think of actuaries as fortune tellers, financial fortune tellers, try to predict the future. Using probability, statistics, and economics to as sort of our tools to try to predict what's going to happen. So here's some examples of future contingent cash flows. And it'll give you an idea of some of the areas that actuaries work in. So a life insurance benefit payment. Okay, so some payment is going to be made sometime in the future, and it's contingent on the person who has the policy dying. So you go and buy life insurance, and well, if you die, you get this benefit. So a pension payment is another example. It's not as morbid. You get monthly payments, and it's contingent on the member of the pension plan being alive. So once they retire, they get a pension each month until they're dead. So an auto accident, you need to repair your car, and but only if you get in an accident. There's a few, not as common examples, but say you're holding a major event, a fundraiser, some sort of giant concert, and you have torrential rain happens to be that weekend. That's going to cause financial loss for you. If it rains, contingent on it raining. If you lose your job, you could lose your job. You have lost wages, but it's contingent on you getting terminated from work. And the last one's kind of a funny example, but it's a real case that happened. A company offered free tacos to all of America if, when they crashed the Mir space station into the atmosphere, and it was supposed to land in the ocean, so if a piece of it hit the banner, they'd give free tacos to all of America. Okay, so that'd be a really high cost to the company, but it's contingent on the fact that the Mir would have to hit this banner in the middle of the ocean. So, this is your part.
My part. So, as Dave mentioned, those are are some of the situations that actuaries are brought in to work on. The people who employ them, the companies that employ them, tend to be insurance companies. So that would be in Vancouver, would be a place like ICBC, Pacific Blue Cross, Industrial Alliance Pacific, consulting firms. This is where we work. So we will work on the things like pension plans. Like a lot of our clients, people who pay us are people who, I'm sure Langara sponsors a pension plan for its employees, and we will do sort of the number crunching, making sure there's enough money, telling Langara how much employees as well as the company itself has to contribute in order to make sure that someone age 30 right now can retire with a lifetime pension at age 60, say. So we'll do a lot of the number crunching involved in that, and the communication of the results and things like that. We also do post-employment benefits, things like dental care after age 65, life insurance. So that's what we do. And those are the two big ones: the insurance companies and the consulting firms. But actuaries also work in things like actuarial evidence. Say if you get in a car crash, your means of making a living have been reduced. Actuaries will be brought in, will give testimony saying, well, suppose the accident didn't happen. Given, I guess, the plaintiff could have earned this much more over this this length of period, and so we're asking for this amount. And they'll bring an actuary to come in and say, sort of testify that this is a reasonable way of doing things, this is a good estimate. And I guess the final point in terms of, insurance companies essentially hire us because they can make money by taking on this risk. In essence, bringing in all this risk, they take premiums in, and actuaries, you sort of calculate the likelihood of people passing away, things like that, things that Dave mentioned, and they aggregate this risk and they can make money. So that's sort of the nuts and bolts of it. And those are the traditional places where actuaries work. Everybody thinks of insurance companies. People who do know what an actuary is when they meet you, they generally say, oh, you work in an insurance company. But actuaries can work just about anywhere in finance. Also investments, we see a good number of our colleagues every now and then you get an email saying so-and-so's left to pursue opportunities in, say, oil and gas hedging, things like that. And really anything to do with risk management, actuaries can be involved in. Really, then we calculate the likelihood of certain events, and we can help a company sort of hedge their risk to certain things.
So I'm just going to go over some key facts about actuaries, or actuarial science. So the main organization is the Society of Actuaries, or SOA, and it's recognized globally. So one of the advantages of that is that there's good opportunities to travel. If you ever want to pursue a career in actuarial science, you can decide one day I want to go work in Japan or China or Australia. You don't have to do a ton of extra work when you go to that country to work as an actuary in general. But within Canada, most of the actuarial jobs are in the east or in the prairies. Vancouver is not a real financial hub, so there's not a ton of financial jobs in Vancouver, so it's kind of a bit of a warning. So Toronto, Montreal, Waterloo, Winnipeg are fairly big cities with a lot of actuaries. Winnipeg has some insurance companies, quite large insurance companies, so they have quite a lot of actuaries. Waterloo, I think Sun Life is in Waterloo. So anywhere there's insurance companies have a lot of actuaries. So some universities in these cities have large actuarial programs, and a lot of actuaries come out of those universities as a result. So yeah, most in Vancouver, as Mike pointed out, most actuarial jobs are in consulting firms, pension consulting, or post-retirement benefits, like health benefits. So, usually to be hired as an actuary, what you'll need to do is pass at least one Society of Actuary exam. So Mike will talk more about the exams in a bit, but there's a series of exams, so what you need to do is at least pass one, and then you'll go into the workforce and continue to study while you work. But to get your foot in the door, one is required at least. So the starting salary for an actuarial student is approximately $55,000. So that's just general. That just happens to be maybe consulting in Vancouver. It could vary in different countries. Generally, actuaries in the U.S. make more. I'd say any actuary working in Vancouver is not doing it for the money. You could go somewhere else and if you really want to make a lot of money, you could go to the U.S. But yeah, the starting salary depends a lot on how many exams you've completed. More exams, you'll be paying a premium for. And this is just an illustration. But we'll show some more, potential earnings on the next slide. Being an actuary is a safe job. You're not working outside. You're working in an office with computer and calculators. It doesn't sound really exciting, but there's some good things. It's safe. You're not going to worry. Nothing's going to fall on you, like that. So generally, the job's 9 to 5. It's a typical office job. You're in an office, 9 to 5. Consulting can be more time demanding sometimes, working late, weekends sometimes. Insurance is known to be more 9 to 5. But because the salary is pretty decent and it's a pretty safe job, it's often ranked very high on the job ranking lists, I suppose. CareerCast.com ranked it number 1 in 2010. It's ranked number 3 for this year. CNN Money and PayScale.com ranked it number 11 in 2010. So it's fairly ranked fairly highly as a job.
So here's an idea of what. I was going to tell you that. These are rough numbers based on some salary survey information that's pretty widely available on the internet. It's a rough. The more experienced you become, depending on the line of work you are, there's also incentive pay. So that's involved too, bonuses and things like that. But this gives you a rough idea of what kind of salaries. And again, it depends on the market. I say starting university graduate, these salaries here will be pretty reliable, like across North America. So yeah. Personally, I fall somewhere below here, so that works. I gotta get better. But yeah. So the people who have heard of the actuarial profession tend to know, if they have heard about it, they think, okay, you work in insurance and the exams are impossible. The exams are not impossible, they are difficult and there's a lot of them, but I think they keep changing the system to try to make it a little bit more reasonable in terms of getting through. Personally, I started writing exams in university, and I finished, so I probably started when I was 20 and I finished when I was 28. Which isn't to say it's like taking 8 years of university. I started working, I did about an exam a year. There used to be 8 exams. So employers tend to be quite helpful. So for us at our job, we have a study policy where, say, 3 months before your exam, you get 1 day off a week to study. The company pays for the books, the supplies, the fee to write the exams, and you get rewarded for passing the exam. So it's not like you're doing 8 years of toil for at the risk of not getting a job. At least once you do a few jobs, generally when you're in university, and you sort of go from there. The exams are very difficult, especially I think when you first start writing them, they're a lot different than, say, a university exam, where it's you have a general idea of what you can expect on a given test, whereas with these exams, it's one of the most difficult tests you've ever taken, and you have very little time So it can be tough, and it takes a little while to get used to. The very first exam I wrote, I failed. I just wasn't ready for it. Next time I passed it, but that's sort of what's expected. There's about a 50% pass rate, I'd say.
Yeah, pass rates are anywhere from 30 to 60%, I'd say. So university exams, you're usually used to, you study hard, you write the exam. Most people in the class pass, some people don't. I'd say in general, that's university. With these exams, you study very hard, and half the people will fail.
Which makes it tricky because especially with your friends and your relatives, when they see you studying all the time, making sacrifices, and then if you pass it, they say, well, of course, I've never studied for anything like that. Of course you passed it. And if you fail it, they think, what's wrong with you? But yeah, that's just the nature of being an actuary. And yeah, that's an average. When you get your FSA, you go to a fellowship conference where they hand you your degree. It's sort of like a graduation. But they tell you, they get the youngest person and the oldest person to stand up. And in mine, it was in Dallas. And people come from all over the world because this is the one place where you get your graduation. There was a girl from China who finished, and she's 23, which is remarkable. Everyone gasped when they heard that because it's amazingly difficult to finish it at 23 to be completely done. And one guy was 55, so you got a big standing ovation. So yeah, and the exams are offered May, November, but there's also an online component now that you can do more.
And it's recommended about 100 hours of studying per hour of exam is sort of the general rule. So the exams are, 3-hour exam is quite common. So 300 hours of studying for that exam is sort of the thereabouts. So it's a lot of studying. But you get, like Mike said, you get time off from work.
So the first exams are on basically statistics and mathematics. So I guess the first one is called probability now. And the reason Dave and I actually both have to confess to being a bit unfamiliar because when we wrote, it was a different system, even though it wasn't that long ago. So, but essentially the building blocks are the same. It's probability is a huge one because what Dave mentioned, the contingent events. So at work, we're always talking about what's the likelihood of something happening. The more likely something is going to happen, the more weight is applied to it financially. So the Mir space station thing had a very, very small likelihood of happening. So there was an insurance company was willing to take that risk. Of course, it also had a big payout. But the later exams get into finance. So things like interest theory. Is everybody familiar with what annuity is? When you retire, say, a pension is an annuity. It's a guaranteed stream of payments, not necessarily guaranteed, but a stream of payments in the future. Say, $100 a month for the rest of your life. That is something an actuary is often asked to calculate, something like that. You can go to an insurance company, for instance. Someone saves up in an RSP till the age 65, and they say, look, I don't want to have any more risk in the market. I would like to transfer the risk of investing, mortality, things like that to you, and in exchange, I'll give you, say, $500,000, and you give me some income every month, and that's something actuaries are often asked to do, and that's something you start, sort of in the second exam there, and you go from there. The later you go, the more specific it becomes. So you see life contingencies. There's a lot of life insurance specific work that Dave and I really don't do much of. So you finish your first chunk of exams, you become an associate, and that's a milestone in the life of an actuary. You effectively become. You get a title. It's something you can put in your business card. It doesn't allow you necessarily everything that a complete actuary can do in terms of someone who's attained their FSA. But it's a lot of people are what you would call a career ASA, and when you're an FSA, you have the authority to sign certain financial documents that you don't have as an ASA, but a lot of actuaries will stop at ASA and because, say, with their career they don't necessarily need it or they want to pursue something else. But it's always a good foundation. And are you more familiar with this or am I?
Well, I think instead of, they used to test economics, applied statistics, corporate finance as part of the actuarial exams. But then they decided instead of testing those, a lot of people take them in university. So what they're doing now is instead of testing those, they're saying, okay, well, you have to have taken them in university and that'll be enough. So economics, micro and macroeconomics. So the courses here that are recognized are economics 1220 and 1221. And you have to have a minimum grade of a B minus. So you can't just pass the courses, you have to attain a certain grade level in these courses. So then you get credit for economics, and then you don't. Otherwise, you can do a test online if you haven't taken those courses.
So yeah, and then the ones available through the website are sort of the exception to the once every 2 year rule with most of the exams.
So someone like me, actuarial science was good because I actually did a physics degree. So I didn't do actuarial math. Like Mike took actuarial math at University of Manitoba, but I took physics, and so I was able to just do the exams. I didn't have to go back to school, take any additional courses. So it's still set up that way. It's, they say if you're taking these courses, you get credit. Otherwise, you can do an exam. So it's good for people, some coming from other fields, pure mathematics or physics, chemistry, or whatever. So.
And even engineers.
Yeah.
And then my last slide here, you finish your ASA, you do those sort of what's called the VE, and then to become an FSA, you become a bit more specialized. You don't have to. There's 2 large exams or 2 6-hour exams to finish, every exam prior to that is universal. So everybody writes the probability, everybody writes the financial economics exam, but here you can take specific exams. Dave took the investment practice, if I recall correctly. I took the retirement benefits practice. That's the type of work I do. But a lot of people are doing sort of what Dave did in terms of it's just another way to diversify yourself and learn a bit more about the profession. So one of the newer tracks and something that's we get a lot of emails about because it's a relatively new aspect of the actuarial profession is enterprise risk management. You'll see ERM a lot. And that's received a lot more attention, especially in the wake of the 2008 financial collapse, where you hear and you read about what some companies on Wall Street were doing, and it's amazing. Like they just ignored very basic tenets of even diversification, leverage, things like that. So this is an area that I think has a pretty good growth potential.
And then just one thing to point out is that this is for what's called a life actuary. There's another path for actuaries that get into property insurance, or home insurance, auto insurance. So if you go to ICBC, they'll have actuaries who took a different, they do the same exams, and then at a certain point they branch off and they do their fellowship exams are different.
Is it the ASA?
Yeah, I think the ASA they're the same,
Yeah.
and then after that they branch out and they do some more things specific. But this is what's called life actuary. They deal with cars, we deal with lives. Anyway, so that's the end of our presentation. Sort of a quick overview of what an actuary does. So does anyone have any questions?
Yes.
Dave said he started out as a physicist. What made you decide to change career paths?
Well, I got a degree in physics. I wouldn't call myself a physicist. But I just knew that after I enjoyed physics, so I did it at university, because to do something for that long, I think you have to enjoy it. But I also enjoyed economics, so I felt that actuarial science was a good mix between finance and economics and science. So it sort of led me to that. I thought I wanted to do something financial after. I didn't want to continue in science. Science. So.
And he says that, but if there's ever any physics-related question in the office, it goes to David immediately. So I would say he's not practicing physicist.
I was going to ask about the size of the actuarial profession in Canada. In the States. How many actuaries roughly are there in Canada?
Oh, Vancouver is starting.
Yeah, that's a good question. I don't know the exact numbers. I wish we included that.
Well, I mean,
think about go ahead.
you see, we looked at Vancouver. Our office has, say, about 10 fully qualified actuaries. About 10. There are maybe 10 or 12. There are 3 firms the size of Towers Watson, say a Mercer, I don't know if you've ever heard of, Aon Hewitt. So you've got about 40, say, there, and then you've got a handful of actuaries who are practicing by themselves or maybe retired, so maybe 60 in Vancouver.
60 or 60 to 80 maybe.
60 to 80 in Vancouver, maybe.
But Vancouver's not a real financial hub.
So in Canada, I would guess it'd be about 1,000.
Yeah.
And you mentioned Wall Street investment. Where were the actuaries during that fiasco?
Well, where were the CEOs? I mean, a lot of the actuaries would have been. Well, you look at the way, say, like a company like Lehman Brothers operated, and you'd have traders who were, taking risks that were way beyond anything they should have been doing. And you're exactly right. They had people who were, there's a term called chief risk officer, things like that. And they had sort of maybe it was in name only. But no, you're exactly right. Someone thought it was a good idea to leverage their company to the hilt on terrible mortgages on people who borrowed without proper income. You don't need an actuary to tell you that's wrong.
That's not. I wouldn't say that's traditional actuarial work, though. I think actuaries are trying to get into that space. But I'd be surprised if at these companies, if there was a senior person who had an actuarial background.
Yeah, and that's sort of like that enterprise risk management. That's sort of what now actually saying like, wait a sec, we would have done differently. You have a question?
Okay, taking your own example,
Yeah.
and you're working on present value calculations. What is the present value of a lifetime career profession of an actuarial consultant?
In terms of salary.
Based on salary, you said
Oh, wow.
50,000, 50,000.
Yeah.
Have you done this for yourself?
No, I haven't.
How about you, Dave?
No, I've never done it. No. But you could. Yeah.
And that's actually a good example. Is what would be involved? You'd say, I'm making X amount today. How much will I make next year? How much will I make in 20 years?
Yes.
And these are some type of things. What are the odds
next
that
40 years.
Yeah. What are the odds that I get fired? What are the odds that when will I retire? If I stay another 5 years, that's when you tend to be making a lot more money in your career. That's a huge difference. So that's actually in terms of the work we do. That's kind of it's a very perfect question.
So, science safety, $3 million would be a good number.
Maybe, yeah, I guess.
I just want the students have an idea about how rich they will be.
The problem is, for me at least, you have to factor in, paying for, everything I pay for. You have to factor that in. But I don't know how helpful that would be. That price tag. Maybe it would be 300, maybe it would be 500, maybe it would be more.
I don't know.
Would it depend on who you work for, essentially?
Oh, absolutely, yeah.
Does that vary? Like, say there's like 4 companies that primarily hire the actuaries in Vancouver, but of those 4 companies, is there like, the pinnacle company and then the like butt-end company? Or are they all relatively getting paid the same across the board?
They're all relatively getting paid the same. It's a free market, so if there was company Y was paying more than company X, everyone's going to want to go work for company Y. So they have to make sure they're competitive.
Though that is a good point in terms of there's 3 big companies in the field that we're in. When I started, I worked for a smaller firm, and I'd say there were 4 of us. There was 2 actuaries, and we definitely got paid less. And that was definitely and on the flip side, there are guys who, there's a guy who used to work for our firm who had started a kind of a splinter firm, a smaller firm that started off quite small, and they eventually sold to a multinational corporation, and he did extremely well. Initially, he took that risk. He took a lower salary, but he would have done 7 figures, 8 figures well.
On your day-to-day work, do you get enough variety of work to keep your interest, or are you doing the same thing? I mean, how do you enjoy your work?
This may not sound well, but the number one reason I enjoy work is the people I work with. We happen to work at a firm with a lot of good people. The work itself, I mean, you're working with numbers at a computer. It's not, we deal with clients sometimes. I mean, we consult the clients, so you have client meetings, once in a while. So that's sort of exciting. But a lot of the day-to-day job is, at a computer, crunching numbers, writing emails, things like that, of that nature. So I wouldn't say it's the most exciting day-to-day work, but it can be interesting. Particular at the beginning of your career, some of the work that, you're doing a lot of data work, it doesn't, it's not extremely exciting, but as you start to develop, you get to do more and more work, and it's very interesting. The first 5 or 6 years of your career, you're just learning so much.
And it keeps you on your toes, like at least, the 2008 collapse happened, and obviously a lot of our clients have very, very large pension funds, hundreds of millions of dollars. So they looked and they lost, $60 million in a matter of a couple months, and that was I mean, very interesting. It was brought a lot of new challenges. I mean, our clients were losing it in some cases. But it is, I do enjoy the work. If you were trying to decide between, an actuary and a race car driver, there's pros and cons as to any, office job. But I enjoy it. I think we have a lot of independence in terms of I can show up if I want to show up, and I have errands to run. I can show up at noon one day, and it's not like someone's on my back saying, "Where were you?" This morning. So you do have that level of autonomy, which is quite nice. The work is interesting; it keeps you on your toes, and it is the type of work where if you don't, the good thing working about a large firm is that we have people who help us keep up to date on everything, because there's all kinds of things: taxation, regulation, updates. Like every conservative government brings in a new rule, we have to adjust our work for that. Every time there's a budget, our work changes a little bit. So
we have to know quite a bit. Like we have to know, provincial regulations, tax regulations, accounting rules, actuarial rules, and these things are always changing. They expect us to know a lot of very different. Even though we're not accountants, we have to know quite a lot of accounting, because companies that have pension plans have to put their pension plans on their books. They have to put on their balance sheet and their income statement. So we have to know how to present those results to the client so that they can use it for their reports. So we have to know quite a bit of information, and that's always changing.
So that makes it less. That keeps you on your toes, and that's an attribute of it. Yeah.
What's actually involved in assessing risk? Can you give us an example? Do you have like a big book of formulas that you use, or is there any psychology or sociology involved?
Well, I use a good example is we do pension plans. So pension, when someone retires, they pay an annuity, or they pay a monthly income to that person until they die. So what we do is we take the person's age, and we have a table of mortality rates, based on a broad population. Someone who's 68 years old, what's the male who's 68? We don't go into great detail like insurance companies. Do they smoke? Do they have, all these things? But someone who's 68, a male, based on this table that we are using, what is the probability that they are going to survive 68 and be there next year. And we do that each year. So there's an example of we take this table, that's sort of a broad statistical table, and we apply it to our this annuity payments. So, and then what we do is we take all these payments and we sort of say, so you take a big population of these people, and on average it's supposed to work out. We're supposed to be able to say, on average, this is how much, how long you're going to pay this annuity for, and discounted in back to today, that's how much it's worth.
I'm sure there's, I'm sure there's some actuaries who work in, I'd say more tangible, like a little bit more exciting. Like you'll see a vacation company that says, if it snows more than 10 centimeters on New Year's Day, everybody who books a vacation gets it free. So that's something that's a little bit more tangible in terms of, okay, historically, how often does it snow 10 centimeters in a day? So you look at that and then you say, okay, what's the cost? Like, how much are we going to have to pay if it does snow that 10 centimeters a day? And then how much money do we have to make so we can pay for our employees, our office, and everything else? So that's, we do that on a much more boring scale.
Anyone watch Canucks? Excellent question. You see at the beginning of Canucks games, Safeway will draw someone's name out, and they'll say, if a player scores 5 goals in this game, that person wins $1 million. So an actuary, probably an actuary would, and this is a pretty easy one, but would say, okay, Safeway is not going to pay the $1 million. Safeway is paying an insurance company a premium to run this contest. If someone actually wins it, the insurance company pays out the $1 million. So an insurance company is going to turn around and someone's going to figure out what's the premium that Safeway has to, what do we have to charge them, so that we can make a bit of money off this. That's kind of an interesting example.
5 goals in a game a couple days ago. That's true. Not from the Canucks, but and they said the last time that happened was 4 years ago or 3 years ago. So
yeah. What about university programs in actuarial science? Both of you sounded like you were hired by companies, and then you started writing the exams. But there are, I know, Waterloo, I think, was the first to start an actuarial science program. There's one at Simon Fraser, obviously, and I think there's one in Manitoba.
it is. That's when I graduated from. So I started writing exams at university.
Oh, okay.
And yeah, so there's an actuarial program there. There's a lot of there's one, Great West Life is a very large insurance company in Winnipeg, so they'll hire a lot of students from there. In Vancouver, SFU has an actuarial program. And we have, I think, about 3 students or 3 employees working for us who went to SFU.
Big in Quebec as well, like Laval, University of Laval, a lot of actuaries out of there.
Is there any value to the graduate degree in actuarial science, or would you say that's not?
Personally, I say no. Not that there's no value. It's
No monetary value.
Yeah.
You're not going to make, you get a master's in actuarial science, you're not going to make any more money.
Also, I'd say there's a risk. Every now and then we'll get a student who says they'll try to become, say, an ASA through university, and we always kind of say, I mean, that's great, but it becomes a bit trickier to the proposition to the employer because they have to pay an ASA more, but you really, in terms of the day-to-day work, you're really no more effective necessarily than someone, say, has 2 exams. So the same kind of applies to someone who has a graduate degree in terms of why not just take the exams? In effect, it is a postgraduate work. It's not recognized as a diploma or in terms of university, but I think it'd be better to learn. Personally, I think it'd be better to learn in the field and while writing exams. You're kind of doing the same, you're getting paid unless you want to teach.
And some people just love actuarial science and they want to, they do university and then they want to get a master's in it. And that's fine if you enjoy it enough. But as far as job prospects go, it doesn't increase your chances of going there.
Any other questions?
You guys worked on the point spread in the Super Bowl yet?
Well, we were saying to Nora earlier that they renovated our office recently and they gave us big whiteboards like this, assuming we do work with them, like fun schedule. there's 2 individuals in our office who it's strictly user handling. So as we speak, they're probably discussing. There was a bet about how many students would show up today, and the guy who said the highest number won. So there's some pessimists in our office. One person was one of the guesses.
What type of students were you guys? Were you guys like A+ students, or were you like B students?
Like A+ right here.
Not A+. Let's say A or B. Sort of student. Like the exams can be quite tricky, and so the exams can be quite. I guess the exams can be quite tricky. Get through the exams. You have to be able to think on your toes to get through them. Like Mike said, it's very difficult because you usually get a lot of A+, B+ students who decide to write these exams, and they've always done very well at the university with little studying often, and then they go and write these exams, and they're one of the 60% sometimes of people who fail, and it's a real ego hit for people to get past that. So.
I'd say I'd be more as a solid B student. I describe myself as more of a grinder, which I think is also can be a good thing in terms of, I mean, we do have to be very technically proficient in terms of the work we do, but I mean, I've written 2 emails this morning to clients. We get calls, especially in the consulting industry, where you have to be well-rounded. There is sort of a stereotype that say and it might sound funny, but actuary stereotype actuaries within the profession, but insurance actuaries, it tends to be less maybe client contact. So maybe if you really loved crunching numbers, that would be a better spot for you. You'd be more comfortable there. There's an actuary on our staff who, he probably hasn't done a calculation in 20 years. And all he does is sell. So he goes to clients, and he's great at it, and he's meeting clients, he's selling them all the different offerings we have. And that's what we need. That gives us work that that pays our paycheck.
So I don't know if we really answered your question there.
That was good. Good range.
Yeah. At the end of the day, study hard, get a good grade. In the workforce, someone who is a C student, and you have someone who's an A student, it doesn't necessarily, other than getting through the exams, once they're working, it's not necessarily going to be the A student is some career is going to be the boss one day kind of thing. It doesn't really work like that. So.
That's the interesting part. I think it tends to level out a bit in terms of different strengths become obvious and different weaknesses become obvious in the day-to-day work. How you can handle stress, how you can manage with, because you don't have just one thing to do today. You have 7 different things, and sometimes they both have to be done at the same time. And you've got to be able to either delegate or work quickly. Or
one thing, when I was in university, which was a very long time ago, but you had to take these take English classes no matter what you were taking. I thought, well, I'm gonna be science, or I'm gonna be in finance. What do I need all these English classes for? And now, spend a lot of my day communicating through reports or emails to clients, and the English and the grammar has to be perfect because you're sending this to someone who's going to read it, and if it's not written well, they're gonna judge you on it. And so, my advice to all these science students and math students is concentrate on your English classes.
Yeah.
So it's a lot of communication, our job. But not necessarily all actuarial work.
You don't listen.
Okay. That's right. Yeah.
How many females in the office? Females, yeah.
You're not allowed to work.
I'll tell you my little background story is I did physics in university, and it wasn't a huge program, but maybe 20 students, and there's one woman in the class. And so when I came to work at Towers Watson, I was pleasantly surprised to see that there's about 50-50. And I would say that's pretty universal for our offices, is that it's about 50-50.
Especially in terms of the resumes we see, it's at least 50% women.
Yeah.
And
if not more, I would say. I would say it
Yeah.
might be more women than men.
I don't know, I mean, I guess the faculty here might have a better, but I keep reading articles like in the Globe and Mail saying that boys are lagging behind girls in school, and I don't know if it's reached university yet, but yeah, in terms of our office, we have, in terms of senior, I'd say the generation above us, like sort of maybe our parents' age, I'd say there were certainly female actuaries, but they were definitely outnumbered by men. But in terms of our office, I'd say it's 50-50 actually. Depends on, one person leaves or goes, there's 40 people, but yeah, very equal opportunity.
Any questions? Thanks for coming, everyone. There's a copy. I only printed a few out, but there's a copy if anyone wants it. If you don't, I won't be offended. And I think we have business cards if anyone wants a business card and want to ask us more questions.
Yeah, feel free to come up. We'll be here for a couple minutes, so if you have any questions.